So just as a reminder, a factor is a whole number at a divisor. So it goes into your number without any remainders. And the two factors that prime numbers have are 1 and itself. So what does this mean? If you look at the number 3, for example, the only factors that can go into 3 are the numbers 1 and the number 3. So it has two factors, 1 and itself. So 3 is a prime number. Another prime number is the number 7. The only factors that 7 has are the numbers 1 and 7. Therefore, 7 is a prime number. Now, numbers that have more than 2 factors are considered composite numbers. So that's pretty much all the other remaining numbers. So for example, the number 8. So 8 has more than 2 factors. Let's write down its factors. So 1 is a factor always. 2 goes into 8 4 times. 4 goes into 8 twice. And 8 goes into 8 once. So 8 has got 1, 2, 3, 4 factors. So because it's got more than 2 factors, it's a composite number. Another composite number is the number 10. What are its factors? Well, 1, 2, 5, and 10. So it's also got more than 2 factors, which makes it a composite number. So that is, broadly speaking, the difference between prime and composite numbers. Now it's worth pointing out that 0 and 1 are not prime numbers. So let's have a look at why. 0 does not have 2 factors, and with the number 1, and students often do make this mistake because they think that 1 goes into 1 and itself, right? So it looks like it's a prime number, but it's not, because what goes into 1? 1 goes into 1, so it's only got 1 factor, even though it's 1 in itself, but it's still only 1 factor. And remember, prime numbers have 2 factors. Okay, so 0 and 1 are not prime numbers. Another one that's worth noting is the number 2, because 2 is the only even prime number. And if you think about it, the reason that's the case is because any other even number is automatically going to be divisible by 2. So when you think of even numbers like 4, 6, 8, 10, they're all divisible by 1, by themselves, and by 2. And in fact, many of them are divisible by other numbers as well. But that's why even numbers are not prime numbers, except for 2. So 2 is an exception, and it's the only even prime number. Another prime number that is interesting to talk about is the number 5. So 5 is the only prime number that ends in 5. So if you think at your divisibility tests, every number that ends in 5 or 0 is divisible by 5. So 5, 10, 15, 20, 25, 30, and so on. So none of these numbers are going to be prime numbers because other than 1 and the number itself, they're all divisible by 5. And of course, many of them are divisible by other factors as well. So no number that ends in 0 or 5 can be a prime number, except for the number 5. So it is the only one that is a prime number that ends in 5. So 2 and 5 are special prime numbers for those reasons. And so prime numbers, like the rest of the number system, they go on infinitely, they never end. But as the numbers get bigger, prime numbers are found less and less. Okay, so now I want to write down a few primes. We're going to try and cover all the prime numbers between 0 and 100. And I'll do it slowly enough and I'll read it out as I'm doing it, so that if you wanted to copy them down on a piece of paper, you can do that along with me. Okay, so primes between 0 and 10. So our first prime number is 2. Next is 3. Then 5 and 7. Those are all the prime numbers between 0 and 10. So now I'm going to move on to prime numbers between 11 and 20. So our first one is 11. Then we have 13. Then 17. And finally 19. So all of those are prime numbers. Now we're going to look at prime numbers between 21 and 30. And there aren't too many here. There is the number 23 and the number 29. Okay, now let's have a look at primes between 30 to 40. So we start with 41, then 43, then 47. Now we're going to move on to primes in the 50s. So 53 is a prime number, as is 59. Next, primes in the 60s. We have 61 and 67. Primes in the 70s. 71, 73, and 79. Next, primes in the 80s. 83 and 89. And last, we're going to do primes in the 90s. Oh, I'm not going to fit that in. So is a prime number. So those are the prime numbers between 0 and 100, and you don't need to learn them off by heart, but it's good to sort of have this list and be familiar with these numbers so that you can recognize them when you're doing a test or an exam or any problem that involves prime numbers. So now I want to solve a few questions involving primes and composites. So we'll start with question number 1. Are the following numbers prime or composite? Okay, so we've got the following numbers. We've got 13, 24, 37, 45, and 63. So obviously, if you have this list in front of you, it's fairly easy to check if they are prime or composite. But if you don't have the list in front of you and you're not 100% sure, then you'll need to just think about what are the factors of these numbers. And if you find that any of them have more than 2 factors, then you know that they're composite. So looking at number 13, we can see that is a prime number. The only factors that it has are 1 and 13. Are 1 and 13. So I'm going to put P for prime. Next, looking at 24. I don't see it in my list of primes, and when I think about it, 24 has more than 2 factors. Just being an even number, I already know it's divisible by 2, so that already tells me it's not a prime number. And it has other factors like 3 and 4 and 6 and 8. So 24 is a composite number. Okay, now 37. Oh, when I suddenly realized that I actually left out numbers in the 30s. Apologies for that. I'm gonna have to go back and put those in. Okay, so let's get these numbers in. Alright, so prime numbers in the 30s are 31 and 37. So when I look at 37, I can see it's a prime number. And if I didn't have this list in front of me, then I would just work out its factors. And you'll find that it has no factors other than 1 and itself. So it's a prime number. Next, I look at the number 45, and I can already see that it's a number that ends in 5. Because of that, I know it's divisible by 5. And that alone already tells me it's not a prime number, because it's got more than 2 factors. It's got 1, it's got itself, but it's also got 5 as a factor. So even though it's actually got more than just those factors, I don't need to run through the rest of its factors. I can already see that it's a composite number. And the last one is 63. And certainly divisible by 3. I know that because 6 plus 3 makes 9, and 9 is divisible by 3. So my divisibility tests tell me that the number is divisible by 3. So that already tells me it's a composite number. And that is question 1 done. Okay, now we're going to move on to question 2. So question 2 wants us to list all the composite numbers between 60 and 80 inclusive. So what that means is that all numbers between 60 and 80, including the number 60 and the number 80, it wants us to list all the composite numbers. So I'm going to start. Number 60 is an even number, so it's divisible by 2, and it also ends in 0, which means it's divisible by 5. So I can already see that it's got more than 2 factors, because it's also divisible by 1 in itself. So it's a composite number. 61 is a prime number, so I'm not going to list it. 62 is an even number, so it'll be composite. 63 is also divisible by 3, so it'll be composite. 64 is an even number, so it's composite. 65 is a number that ends in 5, which means it's divisible by 5, so it's composite. 66 is an even number, so it's composite. Now 67 is a prime number, so I'm going to leave that out. 68 is an even number, so it's composite. 69 is divisible by 3, so it's composite. 70 is an even number, so it's composite. 71 is a prime number, so I'd leave it out. 72 is an even number, so it's composite. 73 is a prime number, so I'm going to skip that. 74 is even, so it's composite. 75 ends in 5, so it's divisible by 5, so it's composite. 76 is even, so it's composite. 77 is certainly divisible by 11 and by 7, so it's composite. 78 is even, so it's composite. And then I can see that 79 is a prime number, so I'll skip that one. And 80 16. That's what that means. Okay, so let's go ahead and look for two numbers. So I'm looking for 16, so I'm gonna go over here. So I can see one possibility is if I take the number 3 and I add it to 13, 3 plus 13 is 16, so that could work. So I could say 3 plus 13. So those are two prime numbers, but when you add them, their sum is 16. But I can also see another possibility, and that is when I add 5 to 11. So when you add those two, you also get 16. So there's more than just one answer. So I could also say 5 plus 11 is 16. So both of these are examples of two primes, but when you add them, they sum to 16. Alright, now we're going to do 36. So we're looking for two prime numbers that when you add them, they're going to equal 36. So I'm thinking 31 plus 5 will make 36. So those are two prime numbers that make 36. But there's another one as well. If I take 29 and 7 and I add them, I'll also get 36. So 29 plus 7 is 36, so two more primes that add up to 36. Okay, next. Question 4 is asking us to find two primes whose product is 55 and the next one is 74. Okay, so product is the answer to a multiplication problem. So now we want to multiply two prime numbers. So I'm thinking 5 and 11. So 5 times 11, two prime numbers multiply together, give us 55. And the next one is 74. So I'm thinking 37 times 2 will give me 74. So 30 times 2 is 60, 7 times 2 is 14, 60 and 14 is 74. So there's two primes that'll give me 74. Okay. Next we do question 5. And it's asking us to find two sets of twin primes between 1 to 100. example would be 11 and 13. So they are separated by the number 12. Okay? And so with twin primes, there's always going to be a difference of 2 between them, because there's going to be one number separating them. So 11 and 13 are twin primes. But there's others. So I'm going to move this one aside and I'm going to go back. So we can even find twin primes here. For example, 3 and 5. Because they're only separated by one number, which is a 4. And what about 5 and 7? They're also twin primes because they just separated by the number 6. Next, we've got 17 and 19, and they are only separated by the number 18, so they're twin primes. Then there's 29 and 31, separated by the number 30. 41 and 43, separated by 42. 59 and 61, separated by the number 60. And 71 and 73, separated by 72. So all of these are examples of twin primes that are between the numbers 1 to 100. So there's quite a few sets. I mean, we only had to find 2, so any 2 of these would work. And now we're going to move on to example number 6. We're going to find prime numbers that are factors of the following numbers. There's 24 and 85. Alright, so this is essentially asking us, when it's asking us to find prime factors, to do what's called prime factorization, or it's also called, see if I can pull that down, it's also called prime decomposition. We do that by using a factor tree. So I will run through these 2 examples with you, but I do have an entire video that I made that is completely dedicated to going over prime decomposition and factor trees, where I go through quite a few examples and I show you exactly how to do it. So if you want to watch that video, I will link it up above. So let's get started. So with 24, what we do is we look for any 2 numbers that when you multiply them together gives you 24. And even though there's more than one option, so you could choose 2 and 12, answer would be, those numbers are going to be